Hi everyone. Today we're going to study continuous random variable, probability density function, and cumulative distribution function. Let's begin with continuous random variable. If capital X is a random variable which can take all values in an interval, then capital X is called a continuous random variable. Let us define probability density function. If capital X is a continuous random variable such that the capital X is greater than or equal to small x minus half of dx, but less than or equal to x plus 1/2 dx, which is equal to f of x dx, then f of x is called the probability density function of capital X if number 1, f of x is greater than or equal to 0 for all x an element of real numbers. Second, the integral of f of x dx with the limits of real numbers equals 1. Let us define cumulative distribution function. If x is a random variable, discrete or continuous, then the probability of capital X less than or equal to small x is called the cumulative distribution function, or CDF, of capital X, and is denoted as capital F of capital X. In the case of continuous random variable, the expected value of x equals the integral of x times f of x dx with a limit on real numbers, while the expected value of x squared equals the integral of x squared f of x dx, whose limits are for real numbers. Let us see this example. A continuous random variable has the probability density function f of x equals k x raised to 4 on the interval from -1 to 0. Find, letter A, the value of k. Letter B, the conditional probability of x greater than -1/2 given that x is less than -1/4. For our solution, we take note that the integral of f of x dx equals 1 for the limits from -infinity to +infinity. Considering the given problem here, we will write now k x raised to 4 dx equals 1 from -1 to 0. Using our integral power rule, we have now k times x raised to 5 all over 5 from -1 to 0 equals 1. Let us attach this constant 5 to k and leaving the x raised to 5 without denominator. And then let us simplify this portion. We have now k over 5 times the quantity 0 raised to 5 minus the negative 1 is raised to 5 equals 1. The 0 raised to 5 is simply 0. The negative of negative 1 raised to 5 is simply negative of negative 1. And this negative and negative becomes positive. So we may write k over 5 equals 1. We can solve for k here by cross multiplying this 5 to the right side. So we have k equals 5. We are able to solve letter A. The value of k equals 5. Now, let us substitute the value of k equals 5 to this function. So we have now f of x equals 5x raised to 4. Solving for b, this is a conditional probability. So this is equal to the probability of x greater than negative 1/2 and x less than negative 1/4 all over the probability of x less than negative 1/4. Considering our function here, we have now the integral of 5x raised to 4 dx, and the limits are from negative 1/2 to negative 1/4. In the denominator, we have the integral of 5x raised to 4 dx, whose limits are from negative 1 to negative 1/4. We write here negative 1 because in the given of the problem, we have a lower limit of negative 1 here. Applying now our integral rule, so we have 5 times x raised to 5 over 5, and the limits are here. Also in the denominator, we have 5 times x raised to 5 over 5. We can cancel this number 5 and the denominator here. Simplifying this, we have now x raised to 5 over x raised to 5 in the denominator. We will write the respective limits here and here. Simplifying this portion now, we have the negative 1/4 raised to 5 minus the negative 1/2 raised to 5 all over the negative 1/4 raised to 5 minus this negative 1 is also raised to 5. Simplifying further, we have negative 1 over 1024 minus this negative 1/2 raised to 5 is negative 1 over 32. In the denominator, we have this value equals negative 1 over 1024 minus the negative 1 raised to 5 is also negative 1. This negative and negative becomes positive. The same thing will happen here, negative and negative. So using our calculator, simplifying our numerator and denominator respectively, we have the corresponding values as 0.030 over 0.999. And this quotient will give us 0.03. This is the answer for problem B. Let us copy this opposite this problem B. So here are the answers for our example. I hope you learned something from this video. See you again next time.